and now we're moving on to our second to last module in the class. We're almost there, and this is on hurricanes, and I'm also going to end by talking just a little bit about other types of extreme weather, things like heat waves, superstorms, and so on. But for the most part, this module is going to cover hurricanes. Now, for us to do that, we need to first understand a little bit about where hurricanes form. Hurricanes are different than many of the storm systems that we've already talked about in this class, because most of what we've talked about in this class is what are called mid-latitude storms, meaning they form in the mid-latitude regions. That's usually the region between 23.5 degrees and 66.5 degrees in latitude. We did an exercise on latitude a few weeks ago. If you don't remember, basically latitude is just the distance from the equator, and the mid-latitudes are sort of the in-between. They're the middle between the equator and the poles. Well, hurricanes don't usually form in the mid-latitudes. They actually form in the tropics. This is a region closer to the equator. And so, for us to really understand how they form, we need to first talk a little bit about what weather's like in the tropics. So let's do that. So first, as I just mentioned, the tropics are defined as a belt around the world, which begins at latitude 23.5 degrees north and ends at latitude 23.5 degrees south. Now, what's interesting about this particular region is that over this region, the sun will be directly overhead at every latitude in this region at least once a year. At least once a year. As a result, these regions are very hot. They get a lot of heat year-round. These regions also tend to have a lot less land and a lot more water. So there's usually a lot more moisture in these areas. Now, we're going to talk a little bit about what the weather's like here. But the one thing I will say is that seasons in the tropics aren't like the kind of seasons that we experience. Leaves don't change colors and fall off the trees in fall. It doesn't snow in the winter unless you're in the really high mountains. No, normally it's warm year-round. Normally it's wet. Usually one season of the year, dry another season of the year. I'll talk about why in a moment. But yeah, the tropics are definitely very different than the kind of weather we experience here in the mid-latitudes. So the reason why there's even any kind of seasonality in the tropics is because of something called the Intertropical Convergence Zone, also known as the ITCZ. The Intertropical Convergence Zone is a band of low-pressure systems that wrap around the entire globe. And on average, they're present over the equator. However, in our summer months here in the Northern Hemisphere, this ITCZ is a little bit further north. During our winter, it's a little bit further south of the equator. It's in the Southern Hemisphere. And this has to do with the position of the sun. During our summer months, the sun is further north. As a result, the ITCZ is further north. During the wintertime, the sun is further south. ITCZ is further south. Now, the ITCZ is actually a big rainmaker. Why? Because it's a band of low-pressure systems. As we've recalled from previous modules in this class, low pressure means rising air. Rising air means clouds. Clouds mean rain. And so, whenever the ITCZ is over your area, you're probably going to be getting a lot of rain. On the other hand, when the ITCZ is not present over your area, it can be substantially drier. One example I'll give of this is Nicaragua. I have friends that live in Nicaragua, and even though Nicaragua is north of the equator, so technically they have the same seasons we do, they actually define their seasons not based on astronomical position or where the sun is at, they base it on when they get their rain. They consider that their winter season, and they consider the dry season their summer season. And it took me a while to finally learn and understand that, but eventually it was like, oh yeah, this is just because it rains during these months and it's not raining as much during these months. So, with that said, the Intertropical Convergence Zone is a main governing component of the weather near the equator. Here's how the Intertropical Convergence Zone looks like. During the months of summer, so we're talking June, July, and August, our summer, the Intertropical Convergence Zone is primarily north of the equator. Now, if you notice, it goes up in latitude, it spikes north a little bit over land and dips south a little bit over the ocean. This has a lot to do with the fact that land heats up more than the ocean does, and so that convergence and that low pressure is more present further north. And then you notice the same thing in January, except for now, instead of it spiking to the north, it spikes a little bit to the south. And the Intertropical Convergence Zone is usually south of the equator in the winter months. Here's how the Intertropical Convergence Zone looks like on satellite. Satellite is one tool that meteorologists use to identify the presence of clouds and storms, and this is what's called a visible satellite image. So basically, the satellite is just looking at the sunlight being reflected off these clouds. These areas where it's white represent areas of convection, areas of taller clouds, showers and thunderstorms. Areas of gray, like up here, usually represent very shallow clouds, even fog. Well, if you take a look here, you can see a pretty well-defined band of these white clouds wrapping around an area just north of the equator. The equator is, don't hold me to this perfectly, but the equator is approximately, I can't see that. Let me pick a different color. Online meteorology bloopers for you. All right, let's do this. The equator is approximately here. And as you can see, the Intertropical Convergence Zone, let me use a different color, I'll use yellow, is right here. So I'm betting that this was probably taken in the summer months. In the winter months, this band of clouds and storms is south of the equator. Now, how does this Intertropical Convergence Zone actually behave? Well, those clouds and storms and those low pressure systems move east to west. Now, this is different than what we experience here in the mid-latitudes. Here in the mid-latitudes, weather systems blow from west to east. Most of the rain that we get here comes from storms that blow from the Pacific Ocean and they travel east. But it's the opposite in the tropics. There's a band of winds called the trade winds, and the trade winds blow from east to west. And so all these storms also blow from east to west. Now, one thing important about the tropics is that differences in sea level pressure in the tropics are very low. So we can't identify the presence of disturbances or tropical storms using normal isobar maps like we could in the mid-latitudes. So we have to look at other things. One of the things that we look at are what are called streamlines. A streamline is simply a line of wind flow. It basically just shows you how the wind is blowing at that particular latitude. Now, normally, these streamlines would just blow straight from east to west. However, in the event that there's some kind of tropical system developing, some kind of stronger low pressure, some kind of cyclone developing, you'll start to see a little kink developing in these streamlines. And I'll show you an image of this in the next slide. And that kink is what we call a tropical wave. These tropical waves are usually the first telltale sign, the very first indication, the very first existence of what may later become a hurricane. Now, the way the trade winds work, before I show you these streamlines, the way they work goes back to the three-celled model of atmospheric circulation. Remember that Hadley cell, Ferrel cell, polar cell that we talked about? That was in module 6. That was several modules ago. Module 6 when we talked about global wind circulations. Well, if you recall that module, what we actually have is we have these bands of high pressure, not showing up well on this image. See if I can use a different color. I'll use black. We have bands of high pressure that are present at 30 degrees north and 30 degrees south. These are what are called mid-latitude highs, also known as subtropical highs. And they're present at 30 degrees north and also at 30 degrees south. At the equator, or near the equator, as we've just talked about, we have the Intertropical Convergence zone. And that's a band of low pressures, like so. Well, if you recall from Module 5, which discussed a little bit about how winds blow, we know that the pressure gradient force accelerates wind from high to low. Now, I'll use yellow here. Accelerates wind from high to low. And based on that, if the Earth wasn't rotating, we would have a band of winds that blow from 30 degrees towards the equator. But wait, winds also have another force that acts on them. Because the Earth is rotating, winds experience something called the Coriolis effect. This causes the winds to steer to the right of their path in the northern hemisphere, so they begin to turn like this, and to the left of their path in the southern hemisphere. So they turn like that. And then these winds converge at the equator. That promotes even more lift, more convergence, more storms. Now, here's how these streamlines look like. These streamlines are lines that you'll see on a weather map, and they just show you how the wind is blowing near the tropics. Normally, they are just straight west to east or east to west lines. So they look kind of like this line up here, just straight east to west. However, in the presence of a tropical wave, what you'll notice is some of these lines begin to bunch up together. The area ahead of where they're bunching up together is called convergence. The area afterwards, as they begin to spread back apart, is called divergence. It's this region right here in between that a tropical wave develops. This tropical wave usually marks the beginning of an area of low pressure. And if all is well with the world and the conditions are right, this low pressure can further develop. It can evolve from just a wave to a full-blown cyclone. Now, we're going to talk more about that next time. But essentially what happens is when the conditions are favorable, when we have warm water, low wind shear, and moist air, that trough, that tropical wave can deepen and organize into a full-blown cyclone. So instead of just having a slightly kinked motion in the streamlines would look more like this. You would actually begin to see full-blown rotation taking place in the streamlines. And this is the indication that a cyclone has developed. Now, tropical cyclones have 3 stages of development. Spoiler alert, we're going to talk about this next time, but the 3 stages are called tropical depression, tropical storm, and hurricane. If you want to learn more about those, check out the next lecture. Until then, thank you for watching.